term which is known as overfitting. Now, how many of you know what is overfitting? How many of you know what is overfitting? Yes, anybody who can define what is the term overfitting? Hmm?
Overfitting is like when a function is trying to fit all the points. Line is trying to fit all the points.
Yeah, so yes, logically you are right. The definition of overfitting is that when the function is trying to match all the data points which are given, it is known as overfitting, right? Now, how do we evaluate it? How do we know? How do we know that? How do we know that there is an overfitting, right? How do we understand that this problem has overfitting? One way, what the definition is given by Deep is that overfitting is something that is trying to fit. So suppose I have, this is not a linear regression, or rather, in this example, if suppose I try to make a function like this, right? Function like this, okay? This is my regression polynomial. Okay, now what is the problem with this regression polynomial? The mean squared error or my RSS is going to be minimum when I am fitting like this. What is the disadvantage of this type of fitting? The disadvantage of this type of fitting is that when a new instance comes, when a new instance is given, it is not able to predict as good as it is able to perform here. Okay. Now I'll give you an example. Overfitting, right? You have a student, right? And when I give you I teach you, right? I give you questions and the student gets 98 percentage, okay, or a CPI of 9.8 or something, right? 9.8, right? And then when it comes to your any other exam, suppose it the same student appears in gate for the same course, is not able to perform that good and maybe ends up into very less AIR, right? Or very less marks rather, right? Now, the performance of the student in the internal exams is very good, and when it comes to suppose not let us not go to the next another exam for the same syllabus. When there is a university exam, the performance goes similarly drastically low, right? Now the meaning is that whatever has been given, the question was asked based on only what questions was already given to you, and answers were given, and the performance was very good. And the moment a new set of questions were asked, the performance is not good, right? Similarly, when there is a training data set, and the training of the model is done using the training data set, and the performance of the training performance, or we call the training error is very less, right? But when you go to testing error, it is very high, or relatively quite high. So when your testing error is very high in comparison to your training error, okay, this is termed as overfitting, right? Because as I showed you in the diagram, in the plot, the overfitting, when it is a matter of two dimensions, just you have an x variable and output is y, it is easier to visualize. But otherwise, how do I know that my system is overfitting? So to check that whether your system is overfitting or not, the good way is that you check your testing error and you check your training error. And if your testing error is relatively quite high in comparison to your training error, then this is known as overfitting. What is the reason for the overfitting? The reason for the overfitting is that your model has actually fitted itself so well in the training error, in the training data, that it performs extremely good in your training data. But when it comes to generalization, which is the basic objective of this model, it is not able to generalize properly. Right? So this is known as overfitting. Am I clear with the definition of overfitting for now? Okay. And now the solution. So whenever we are going to learn any algorithm, we are always going to target and always going to see that how this overfitting can be handled, because most of the models are always going to showcase this challenge or problem of overfitting, and there are different ways and means of handling this problem of overfitting, and how are we going to handle this overfitting. Now, to handle this overfitting, we will modify our j theta a little bit, and we are going to add a new parameter which is known as a regularization parameter or a shrinking parameter. In some of the literature, you will see the a term and as shrinking parameter, right? Also, this is termed as a ridge regression. The ridge regression, because the objective function is modified to for this term to be added, and this type of regression is also termed as a ridge regression. Okay. So now what happens that your j theta is modified as 1 upon 2m summation of I is equal to 1 to m s theta xi minus yi square. So up to this it is same. The only thing that we are doing is we are adding a term lambda. Summation of j is equal to 1 to n theta j square. What is the range of this lambda? Lambda is equal to 1 to infinity. Okay, 1 to infinity. So this is equal to the smallest value that you can take is 1. You can go to any level to infinity. So your regularization parameter is a value which is always greater than 1. Okay, now what is the task? What is the magic that it is doing? The magic that it does is that it tries and moderates or it tries to strike a balance between the learning and reduces the parameters theta such that it doesn't the values, the theta values or the coefficients are not so very large or so very dominating that it almost becomes as by hearting your training data, right? And how it does that, if you differentiate it, now I've rewritten that. Now j theta is updated to this ridge regression j theta, and theta j as usual is equal to theta j is equal to theta j minus alpha del by del theta j theta. Now, for this shrinking or penalizing your coefficients, your regression coefficients, we never penalize or we never shrink the coefficient theta 0, right? We never do that. Now, what is the reason for that? Anybody can share that? What is the reason that there is no need to shrink or to manage or to moderate the value of theta 0? Any reason for that? Or do you see any logic behind it? Anybody sees any logic behind it? Okay, so let us rewrite our h theta, right? We rewrite our h theta. So h theta can be written as theta 0, right? Theta 0, x 0 I'm skipping for a moment because x 0 anyways is 1, which we understood very well. So theta 0, theta 1, x1 plus theta 2, x2 plus theta 3, x3 and so on, right? Suppose we had only 4 parameters. Just 4 variables, so theta 4 x 4. Okay, so 4 attributes, this is what it is. Now what is theta 0? Basically theta 0 can be termed, now what is the value of our h theta or our estimate when all our input is 0? When all our input is 0, that is when your x1 is equal to 0, when your x2 is equal to 0, when your x3 is equal to 0, and when your x4 is equal to 0. What is your estimate? What is your estimate?
Swings toward the zero.
Sorry.
Swings toward the zero and the underfitting condition. This can be helpful.
Deep, your voice is not clear. What we are shrinking towards 0? I didn't. I'm asking that when my all input attribute or all my input variables are 0, that is x1 is equal to 0, x2 is equal to 0, x3 is equal to 0 and x4 is equal to 0. What is the value of my estimate? That is, what is my h theta? You can write in the chat window if your voice is not clear. Do you get my question, all of you?
Yes, ma'am. Theta 0.
So it is going to be theta 0, right? Theta 0. Or what we can understand with this theta 0, the meaning is that even if the size of the house is 0, even if the age of the house is 0, all the input values are 0, this comes to be as the basic average value, right? Or this is termed as the average output when all your inputs are 0, right? So there is, or as when we have talked about your two-dimensional value x and y, this also is termed as your y-intercept, or it passes through the value when all other values are 0, right? Now, so therefore, we are not going to touch this theta 0. We are not going to touch this value. We are just going to update our theta j updation equation based on our ridge regression. Okay. So, okay, let us see now how do we do that. Okay. Okay. Now, when we see that this theta j, I've written this, when we differentiate it, after differentiation, I get alpha upon m. This is the equation. Any trouble in differentiating this equation and getting this equation? We have already done it, isn't it? We have already done this. Any difficulty in doing this? It would be y-intercept theta. Yes. I hope there's no difficulty in doing this, right? Now, when we try to rewrite this equation, what we get is theta j is equal to theta j. I'm going to bring this term out, and what I see is that this is equal to minus alpha upon m into lambda theta j, right? Theta j and minus alpha upon m, and the same thing, summation of I is equal to 1 to n h theta x x j x h theta x minus y, and this is I, this is I, and that's it, into x j m. Okay. So h theta x, I will write it like this. Okay. Okay. Now, when we see this equation, what is the observation? When we see this equation, our theta is going to be this. So what we see is that when I try to update is the theta j becomes 1 minus alpha lambda upon m and into theta j. Now, usually this is a value which is smaller than 1 learning rate. This is a value which is greater than 1, and usually of a very high number divided by m, which is again a value which is greater than 1. So this entire thing is surely going to be less than 1, right? So alpha lambda upon m is going to be less than 1, right? And when this is less than 1, it means that this is going to be 1 minus some value which is less than 1, a positive value which is less than 1. So it is going to result into either zero point 0.8 or zero point 0.9 or something. So what it is doing, it is saying it is 0.9 of theta j minus, and then the usual updation, which is this, right? Which is this, right? So this is how my theta j is going to be updated. So what is happening, that my theta j earlier was being updated on the complete value. So earlier, if the value of theta j was suppose 29, then 29 minus some value here, that value is suppose zero point 0.3 or zero point 0.4, then it would be 29 minus 0.3. But here what we are doing, we are also shrinking it by this factor. we're also shrinking it by this factor, which is 0.9. Now, what is the advantage of shrinking? Now, you see this graph, right? You see this graph. This graph shows, this is for the credit card data, where these are the different parameters, your different coefficients for income, limit, rating, and student yes or no, something like that, right? Now, if you see that for a smaller value, this is the lambda axis. For the smaller value of lambda, that is, and for the larger value of lambda, if you see, as the value of lambda is increasing, you see that your all the coefficients are moving towards zero, whereas all your coefficients had a value, this coefficient had a value of 400, this coefficient had the value of minus 300, and so on. So the income had a value of minus 300, and we see that as your lambda is increasing, the value of your thetas is shrinking, and it is shrinking to zero. So if your lambda goes very high, so let us come back here again. If your lambda goes very high, and the value of lambda is very high, then this may lead to making this theta j almost equal to zero, right? It may lead to moving it, it will come closer and closer to 1, and this may lead to 0, and hence my theta j will be always 0, and it will not be actually a learning model at all. It is going to be a simple, a dead learning model which is not able to predict anything meaningful, right? So I'll repeat again, there is a problem of overfitting. This overfitting is because of the dominating coefficients. These coefficients are so strong and so large in their magnitude that they tend to overpower the prediction and always predict according to their its training data. Now, the importance of this regularization parameter is twofold. It ensures that there is a learning and your data is fitting to the training data, but it is also keeping the value of the parameters low. It doesn't allow it to become as large as 400 or as large as in the negative direction as minus 300. So it tries to manage that, and if you increase the regularization parameter very large, it will lead to all zeros, and because of the zeros, it will always predict only one value, which is theta zero. Always it will predict one value, which is theta zero. Because what is happening? Your h theta is equal to theta 0 plus theta 1x and so on. If all this theta 1, theta 2, theta 3 are reduced to 0, no matter what x input you give, you will always receive only one value, which is theta 0. Do you get me? All of you? Do you understand what I'm trying to explain?
Ma'am, can you please repeat the second point for the importance of regularization parameter?
So what I'm trying to say is that there is a little modification in the j theta, and that modification is uh, trying to balance between learning and overlearning, right? So it is not allowing our theta values, which are the coefficient values, to be very large in magnitude. So what it does, we are adding a penalty term or shrinking term, which is known as this term, which is this term, which can be termed as a penalty term or a shrinking term. Now, this term, when it is added, and our entire learning is going to be based on this ridge equation. एंटायर अब अभी तक लर्निंग आपकी जो थीटा अपडेट्स हो रहे थे वो कैसे अपडेट हो रहे थे, इस इक्वेशन के बेस पे अपडेट हो रहे थे. नाउ योर वैल्यूज ऑफ थीटा आर गोइंग टू बी अपडेटेड बेस्ड ऑन दिस मॉडिफाइड रेज इक्वेशन. Okay, now this equation, when you try to, now so your j theta is modified, is updated, and this gets your value, and finally the effect of this can be seen here in the term like this. I will write it here clearly. So you can see that your theta j is equal to 1 minus alpha lambda upon m into theta j minus del by del theta of that. Rather, I will write it into alpha times upon m into summation of m h theta x minus y I into xi. ठीक है xi xg xg है ना. तो आई होप दिस इज क्लियर टू ऑल ऑफ अस. ये इक्वेशन हमारा आया. ठीक है. ये अब ये जो इक्वेशन आया इसमें अल्फा की वैल्यू क्या है? लर्निंग रेट है. लर्निंग रेट की वैल्यू हमने क्या डिसाइड की थी? 0 से 1 के बीच में होगी लर्निंग रेट की वैल्यू, है ना. तो what is this? 0 से 1. So this value is smaller than 1. What is lambda? We said lambda is going to be from 1 to infinity. So it is going to be greater than 1. It can be 1,000, 100, 10,000 and any value. M is our number of training examples, right? So this value is always going to be positive, right? Always going to be positive. And as lambda increases, this value is going to increase, right? This value can maximum reach, right? Can maximum reach approximately 1, right? So, because we are assuming that this lambda would be some way close to our number of learning examples, so we will assume that it reaches to approximately 1. When it reaches to 1, this will make our theta j multiply with 0, and this theta j becomes 0, and basically this entire thing, all our parameters would shrink towards 0. This all parameters would shrink towards 0. Now, when this is not so high, when it is a little reasonably low, so suppose the value is zero point 0.8 theta j, right? 0.8 theta j. So when my theta j was updating earlier, it was theta j is equal to theta j minus something. Now what it is? It is theta j is equal to 0.8 times theta j. So what we are doing? We are shrinking our value. So suppose earlier theta j was 400. We said 400 into 0.8. 8 fours are 32. So 400 becomes 320. Okay, 400 becomes 320. And now 320 में से भी आप subtract या add करेंगे depend upon your gradient. तो आपकी जो वैल्यू पहले 400 थी वो 320 हो गई. उसमें से सब्ट्रैक्ट या ऐड होगा विच इज डिपेंडिंग अपॉन योर ग्रेडियंट. तो क्या हुआ? आपकी वैल्यू का जो मैग्नीट्यूड है जो 400 की रेंज में था कम होकर के 320 की रेंज में आ गया. ठीक है. इसलिए इसको पेनल्टी पैरामीटर, रेगुलराइजेशन पैरामीटर, पेनल्टी पैरामीटर या रेगुलराइजेशन पैरामीटर या रिच पैरामीटर भी कहते हैं. ठीक है. विच इज टर्म्ड एज लैम्डा. Am I clear now?
Yes.
Okay. Any further explanation required in this, in anything that you want to understand in up to this? So whenever now in the labs, what we are going to do in my previous lab session with the other batch, I explained gradient descent. We actually did the implementation of gradient descent from scratch, where we had written our own equation, theta j is equal to theta j minus something something. And now we are going to rewrite our equation with this regularization parameter, that is theta j is equal to 1 minus alpha into lambda upon m into theta j. So this is what we are going to do in our labs, and we are going to, now your task would be, as I in the previous lab also, I gave you the code, but I asked you to say, to actually plot it for different learning rate and so on. Similarly, we are going to analyze that how does your value of theta changes with the regularization parameter, how is your value of um, alpha, value of your training data and your testing data changing, training error and testing error changing with increasing regularization. So ideally what will happen that when your regularization parameter is close to 1, your training error will be very small and your testing error will be large. As you increase your regularization parameter, you will see that your training error is increasing, your training error is increasing. Mind it what I'm saying, right? It means we are allowing it to make more mistakes in the training phase. We are allowing it to make more mistakes in the training phase. So this is the increasing value of lambda. This is our error. This is the graph for your training error, and this is the graph for your testing error. So you will see that with increasing lambda values, you will see as your training error is increasing, your testing error is coming down, and at some point you will see that they both crossing each other. Okay, depending upon different scenario, we are going to see it in the lab that how with increasing lambda values, that is with increasing regularization parameter, how your training error is increasing and how we are allowing our system to make more mistakes during the training and during the testing. It slowly, the generalization becomes better and your testing error reduces. And we are also going to compare the absolute mean square error or the mean square error without regularization parameter and with regularization parameter, meaning that what is the j theta value without your this term. So what is the j theta value at the after learning or the plot of the j theta with the, when we use our j theta function as this and when we use our j theta function without this additional term, that which value is lower? Is this value smaller or is that value smaller? We are going to analyze both the things. That will give you a good insight into how your regularization parameter is helping to combat the problem of okay. So this is how we are going to handle the overfitting problem when we are implementing using a gradient descent algorithm. Right now, when we are implementing the same thing using normal equation, right? I hope I have done normal equation in the class. We completed normal equation in the class in our last session.
Yes, ma'am.
Yeah, so when we are doing normal equation, we are going to do, we had written a normal equation as x transpose x inverse into x transpose y. I hope this was the equation, right? And now we are going to modify this again. We are going to say this again, and we are going to check that our theta is going to be x transpose x plus lambda times, and we are going to add a matrix, and that matrix is 0 and 1, 1, 1, 1 and 0 in all other places. And then we are going to find out inverse and then x transpose and y. Can somebody tell me what should be the dimension of this equation, this matrix? Can somebody tell me what should be the dimension of this particular matrix based on what we have done in our previous class? What should be the dimension of this matrix, which looks like unit matrix, except that at the 0, 0 position or at the first position, diagonal position, we have a 0 instead of a 1. What should be the dimension of this matrix? Do you want to work out the dimension of this matrix? So suppose the dimension of this x would be n cross n. Very good. It is going to be n cross n, right? N cross n. So if suppose the number of attribute that we have or n is the number of what do you call it? The number of attribute is 3, right? The number of attribute is 3. So the Finally it comes out to be 4 because we also add x0 term, so this becomes 4. So in that case the dimension of this is going to be 4 cross 4, right? So you can say n cross n or n plus 1 cross n plus 1 or whatever you're following the convention, right? So this is how we, why are we putting a 0 here? Any guesses why are we putting a 0 here? Any guesses why are we putting a 0 here?
Because we don't want to penalize theta 0.
Yes, because we don't want to penalize theta 0, as we have discussed in the case of gradient descent, we don't want to do that. Therefore, we are not penalizing our theta 0 in our normal equation as well. And this is what is going to be our equation for implementation when it comes to normal equation. Okay, I'm not writing I intentionally because there is a 0 here. Okay. So this is how we are going to write our updated equation, and similarly we are going to plot it for different values of lambda in normal equation also. Now we have to see here that in this case, in this updated equation, for different values of lambda, for different values of lambda, you will have different thetas. You are going to have a set of theta which is going to be different for every lambda, right? So when I take my lambda is equal to 1, my set of theta, so you can see it in this, right? When I take a value theta is equal to 1, my set of theta is going to give me minus 300. It is going to give me 100, 200, and 400. So this is my first set of theta, right? My next set of theta is this, right? When my value of lambda is somewhere 10 or something, right? At that point, I'll have my this. So this is my theta 1, this is my theta 2, theta 3, and theta 4. So my theta 1 is somewhere which is 380 and 210 and 100 and something else, right? So my value of theta is going to change for every value of lambda. So the set of theta that we obtain for every lambda is going to be different. Okay, so that also we have to see. Then only we will be able to plot something like this. And this and what is the interpretation of all theta being 0? What is the interpretation of all theta being 0? It is a very, very generic learning model. It means it no matter, or a zero variance learning model. Zero variance learning model means what? That no matter what input you give, the output remains the same. The output remains the same, which is equal to theta 0 or always 0 or anything like that. But the output remains absolutely 0 no matter what input you give, right? Because all your parameters, so basically it is as good as zero learning model. Okay, so that is, I hope I am able to convey you the concept of regularization. Yes. Okay. Now, let's move to the next topic, which is polynomial regression. Right? Polynomial regression. Now, what is the meaning of a polynomial regression? The meaning of polynomial regression is that it is not necessary that every time your data fits well to a line, to a straight line. It may so happen that you require a different function to fit in your data, right? So if in case, for example, in case of linear equation, the number of coefficients that you had, if your number of attributes are n, the number of coefficient is n plus 1, right? So your input variables are x, and then and you are talking about a linear regression, the number of coefficient that we get is always n plus 1, right? If suppose I say that now I have only one input variable, which is x, and I change that, okay, I don't want a linear relation, but rather a polynomial relation is required. Why? Because the data, if you see, can I? So the data is not fitting any linear boundaries. Any line is not fit. Is not. a good fit. So you need a polynomial that fits it better. So we say that a polynomial model of order 2, right? So what do we say? That this is a polynomial order, is relation of order 2 or of degree 2. So this is a polynomial. What is the degree of this polynomial? The degree of this polynomial is 2. This is a polynomial of degree 3, right? And with just one variable, and output variable of course 1, you see that as the degree of the polynomial is increasing, the number of the coefficients that you need to learn would increase, right? So if I say that I have one variable and the degree is 2 or degree is 3, if that is the case, then if the degree is 2 in one variable, if the degree was 1 in one variable, the number of coefficients was 2. If the degree is 2 in one variable, the number of coefficients is 3. If the degree is 3, it is equal to 4. So in case of one variable, right, if the number of variables change, what would happen? So if I have one y and there are two attributes x1 and x2, and I say that the degree is 2, how my equation would look like? How my y or my h theta would look like? It is going to be theta 0 plus theta 1 x1 plus theta 2 x2. After that, what? Tell me. How should it look like? I'm saying that in two variables, degree is 2. How it should look like?
Theta 2 x2 square.
Okay, so theta 3, because we already have used up to theta 2. So you want to say theta 3 here?
No मैम theta 2 x2 square नहीं आएगा x2 का square.
अच्छा, यहाँ स्क्वायर लिखना चाहते हैं? हाँ ठीक है, और फिर that's it?
Yes.
Okay. Yes. Others want to comment?
We convert to linear equation.
We can convert it into linear equation.
Yes, ma'am.
Okay, so what is that linear equation? It is theta 0 plus theta 1 x plus theta 2 x2. That's the linear equation. Is this degree 2? Is the degree of the polynomial 2?
No, ma'am. We converted into the non-linear to linear.
Yes, so I don't want, so means I'm asking that how my x theta would look like if it is not a linear equation, it is a polynomial equation in two variables with degree 2. How my equation should look like? That's what is my question. आपको दो वेरिएबल f of xy लिखना है, एक पॉलिनोमियल लिखना है f xy विथ डिग्री 2. तो पॉलिनोमियल क्या होगा? क्या होगा? a प्लस b x प्लस cy प्लस d. बोलिए. इसमें तो मैथ्स है सिंपल, कुछ मशीन लर्निंग नहीं है. xy प्लस e x स्क्वायर प्लस f y स्क्वायर. What? Yes or no? Did you get what I'm asking? Hello? Ask me if you don't understand.
Ma'am,
बोलिए.
ma'am, can you please repeat the question?
Yes, I'm saying that if you need to write a polynomial in x and y, that is two variable polynomial, right? And the degree of that polynomial is 2. What that equation would look like? Generally, if I ask you that write a simple quadratic equation in one variable, you simply write right? A plus bx plus cx square. ये लिखते हैं आप
Yes,
एक जनरल है ना, ये जनरल क्वाड्रेटिक इक्वेशन है, या फिर ऐसा बोले इन वन वेरिएबल अ पॉलिनोमियल विद डिग्री 2, है ना? इसमें कोई दिक्कत है?
नहीं मैम, ये तो आता है।
ये आता है। अब आप, मैंने कहा ये एक वेरिएबल की जगह दो वेरिएबल, तो आपका जेनेरिक पॉलिनोमियल इक्वेशन क्या होगा?
ax square plus bxy plus cy square.
हाँ, ए एक्स स्क्वायर प्लस बी वाई स्क्वायर प्लस सी एक्स वाई, हाँ बस दैट्स इट।
Uh, Actually, there will be, ma'am, we need to add another constant for the zero integrator.
हाँ बोलते जाइए ना, अब डी ऐड कर दीजिए, किसने?
Plus d.
दैट्स इट।
There may be dx or
डी
dy
एक्स
dx and dy.
Plus
ई
ey.
वाई प्लस एफ, वही तो हम लिख रहे थे यहाँ पे, थीटा 0 प्लस थीटा 1 x1 प्लस थीटा 2 x2 प्लस थीटा 3 x1 स्क्वायर प्लस थीटा 4 x2 स्क्वायर प्लस थीटा 5 x1 x2। डिग्री का मतलब क्या होता है? डिग्री ऑफ अ पॉलिनोमियल मींस व्हाट इज द हाईएस्ट पावर इन दैट इक्वेशन। Okay, if you remember polynomials that we had studied somewhere in our grade 7 or 8, the degree of a polynomial means what is the highest summation of the variable, right? What is the power of the variables that we are using? So when we are saying degree 2 means the highest power that a term can reach is 2, right? And you see the highest power is 2, x1 x2 makes it 2, x1 x2 square makes it 2, x1 square makes it 2, x1 is 1, and the smallers are allowed, right? It's not that all of them should have only 2, power 2. So this is because in the quadratic equation also you see we have dx. That's the reason I gave you this example. You only had to extend it to two variables, right? Now we have theta 0 plus theta 1 x1 plus theta 2 x2 plus theta 3 x1 square plus theta 4 x2 square plus theta 5 x1 x2. So what I'm trying to make you understand is that as the number of variable increases and as the degree of the polynomial increases, the number of parameters which are required to be learned increases in a very fast rate. Do you see that? Now just two variables, degree 2, what we see is that the number of parameters that we need to learn is 5. Okay, so now we have to learn 6 rather, because the count starts from 0. So the number of parameters that we need to learn or update is 6 parameter with degree 2. If it is with degree 3, if it is with degree 3, you can keep on adding and you can see that you will have all the possible combinations. And it may so happen the final answer that you get may have some of the terms as 0. You may have your x2 as 0, you may have your x5 as 0, and therefore this term doesn't exist in your final relation. But when we are trying to create, you remember when I started teaching you or in the lab session, I told you the first thing that we do is we create a framework, right? And then we update this values of this framework based on our training data. And what is the outcome is the learn model, right? So this is the skeleton that we are going to begin with. After we have learned, it may so happen that this turns out to be 0, this turns out to be 0, and our final learn model do not have any of these terms. It has only these terms because all other coefficients were insignificant. Okay, so it may happen, and it may so happen that you are trying to learn a polynomial with degree 2, and all your degree 2 coefficients are insignificant, and it turns out to be a linear model at the end. That also is possible. Okay, so this is just the realization of how your polynomial regression equations would look like, right? Now, how does it learn, right? So let me get rid of all that. Okay. Yes. So now, as you can see that the skeleton that we want to begin with is going to be theta 0 plus theta 1 x plus theta 2 x square, or theta 0 theta 1 x plus theta 2 x square plus theta 3 x cube. The degree is 3 here, right? So this is what is going to be our learning model. Now, it is how we can learn, how is it possible to learn this using a similar gradient descent. I We had x, we had y, I add x square here, I add x cube here, and we try to add. So this now behaves as if they are the three attributes, as if this was x1, this was x2, and if this was x3, and try to learn our theta 0, theta 1, and theta 2, which are going to be coefficients of this. And as we were learning in the case of our linear models, and we should be able to get the answer, isn't it? Do you agree with that or not? Do you agree with this or not? Do you understood what I'm trying to say?
Yes, ma'am.
Yeah. So what I'm saying is that if you can easily extend your understanding of linear model to non-linear model or polynomial regression as well by adding columns which are square or cubes of your input x and x square and x cube, and then extend it as a linear learning model. The parameters of theta 0, theta 1, theta 2, nowhere we differentiate it with respect to x. All the places were differentiated with respect to theta 1, theta 2, and theta 3. So even if the degree of x is changing, anyways it was considered as a constant. And whenever we were multiplying it with x1, x2, and x3, we will multiply it with x, x squared, and x cubed. That is what we are going to multiply it with in the update equation. Okay, and we should be able to get the similar model. Okay. So implementing this also should not be very difficult. Am I clear?
Yes, ma'am.
Yeah. Okay, so I'm going to start from here only, from the polynomial regression tomorrow again. Okay, and if you have any queries in what I have taught today, we can discuss it again. I think I have a lecture tomorrow also. Tomorrow I have a lecture yes, tomorrow also I have a lecture. So we can extend our discussion again tomorrow if you found some of the topics a little difficult. And there is a very interesting book that we can use for this particular topic. And the book is, you can download it from here. Writing it in the chat window, statistical machine learning. Okay, this is a very good book, and the approach is very similar to what I'm teaching in the class. Okay, and this link you can copy, and this I downloaded it from this link, this PDF, and this is a very nice book and very nicely explained. So you can refer to this book for all the statistical, especially for this regression.